Okay, now we're still on page 357, section 6.1. I want you to look where it says equivalent inequalities. This is right underneath the guided practice of numbers 1, 2, and 3. Just as you use the properties of equality to produce equivalent equations, we would use properties of inequalities as well. These are called equivalent inequalities. And like I said, they're pretty much the same steps that you're accustomed to using with equations. All right, so let's go ahead and look at the first one, which is the addition property of inequality. And basically, if A is greater than B, then A plus C is still going to be greater than B plus C. So, like for instance, if 3 is greater than 2, then 3 plus 4 will still be greater than 2 plus 4, because 3 plus 4 is 7, and 2 plus 4 is 6, and 7 is greater than 6. Okay, so we see how this works. It's the same thing. If A is less than B, then A plus C will still be less than B plus C. And then also it works for our greater than and equal to and less than and equal to. So if A is greater than or equal to B, then A plus C is going to be greater than or equal to B plus C. And the same thing for A is less than or equal to B plus C. A is less than or equal to B, and if we add C to both, the inequality still remains the same. Okay? All right, so let's look at example 3. Now here we see an inequality equation right here. So we're going to let this one stand out. X minus 5 is greater than negative 3.5. Now, I'm going to use the property of addition, the inequality property of addition to solve this because we're subtracting 5. And remember, always use your inverse operation in order to get x by itself. So, we're simply just going to add 5 to both sides here. Okay, so by doing that, negative 5 plus 5 cancels, and we have x. And then negative 3.5 plus 5 equals 1.5. So we see here that x is greater than 1.5. That is our solution. Now to graph this, I just set up a little number line here. We know that 1.5 falls between 1 and 2. Because it's greater than, it's going to be an open circle. And we will highlight everything to the right of my open circle. Now to check an inequality, what I'm going to do is I'm going to take the original equation and I'm going to pick a value that is greater than 1.5. Now, I just went ahead and went along with the book in the example, and I chose 6 because 6 is greater than 1.5. I could have used 2, I could have used 4, any value greater than 1.5. So I put in 6. 6 minus 5 is 1, and 1 is greater than 3.5. Now, is that a true statement? And it is. We know that 1 is greater than negative 3.5. So therefore, my solution does check out here. It's okay. All right?